Good afternoon, class. We are looking at exam 2 review, covering sections 3.2 to 3.5. First off, put up some information regarding logarithmic properties, because when we did the exponential differentiation, we had to use that. So I'm going to remind you of that. And we will revisit this for the next exam. So we have general definition and how we go from a log to the exponential format, general properties, natural log when the base is e, common log when the base is 10, and if we have log x base b equals y, take a look at the arrow. This is our base, this is our exponent, this is our argument. So that's how you can see the relationship between the two. We discussed a lot of differentiation formulas, from the definition to basic differentiation formulas regarding a constant, power rule, exponential rule, and trigonometric functions. For example, the derivative of sine is cosine, so on and so forth. Then we added the product rule, the quotient rule, and now, of course, the chain rule. So we want to go over basically questions we've seen, and the first one, we are going to rewrite this as 2 over 9 x to the power of 5 minus 9, which is negative 4. So if I want to differentiate it, I get 2 over 9 times negative 4 x to the power of negative 4 minus 1 makes it minus 5. We rewrite this accordingly. For part B, anytime we are dealing with a rational expression, the very first thing is, can we simplify this? This fraction will give us 10. This one will give us minus 7x, and therefore the answer is 10 minus 7x. The derivative is simply minus 7. To differentiate exponential functions, the derivative of e to the power of x is itself, or it's always the case. If you have e to the power of kx, then by the chain rule we multiply e to the power of kx by k. If we have e to the power of g of x, by the chain rule we multiply e to the power of g of x by g prime. And if the base is anything other than e, I went over those properties, and so we end up with the function itself, because it's an exponential format. Since the base is not e, we need natural log of the base according to the logarithmic properties, and of course the derivative of the exponent by the chain rule. So for this case, it's an exponential function. We needed itself, 2 to the power of 7x. The base is not e, so we need ln of 2. The exponent is a function of x. By the chain rule, we need the derivative of that, which gives us 7, and we are going to rewrite this in the following manner. In this case, the chain rule is really explained very well. Cosine 2x, and as I've been telling you before, anytime you have a case like that, the way you do it, just read cosine, pause, so you can see the shell function is cosine, therefore the derivative is negative sine. Every sinusoidal function, every trigonometric function has an argument, so you write the same argument by the chain rule times the derivative of 2x, which is 2, and we put it in proper order. Perhaps if we rewrite the second one as cosine x to the power of 2, then we see the extended power rule. So y prime is n, which is 2, g of x to the power of n minus 1, which is cosine x to the power of 2 minus 1, or simply 1. And then the derivative of cosine x by the chain rule, which is negative sine x, and we put them together. Y prime is negative 2 cosine x sine x, or sine x cosine x. The last one, again, we're going to read as cosine and pause. Therefore, its derivative is negative sine. Every trigonometric function has an argument, so we write the same argument by the chain rule. We multiply by the derivative of the argument, which becomes 2x. We rewrite the answer in this format. We are done. Sine squared 8x. Let's rewrite that. As sine 8x to the second power. Let's use the extended power rule on that. 2 becomes the coefficient. Sine 8x to the power of 1. We don't have to write the power of 1. And now the derivative of sine 8x. So sine gives you cosine 8x. And the derivative of the argument 8x gives us 8. Put them all together in a proper order. 16, because 8 times 2 is 16. Sine 8x, cosine 8x. By the way, some of the questions come from some of the practice tests you've had, such as mixed derivative practice, or even some homework that are in the form of a PDF file. It's for the sake of practice. I hope you are doing those. So we want to differentiate this, and this is FG, meaning we are going to use the product rule. So to use the product rule, we need f prime, the derivative of 3x is 3 times g, plus we need g prime times f. So what is the derivative of 3 to the power of x? Since it's an exponential function itself, since the base is not e times ln 3, and then times f, 3x. In other words, this is f prime g plus g prime f. Notice the exponent on 3 is 1 here, same thing here. And therefore, we can say this is 3 times 1 plus x or x plus 1. This one and this one. The same thing. So from here, ln3 is left, x is left. So if we take this one out, this gives us 1, and this gives us ln3 times x. Now ln3 times x, we put the x in front because otherwise one may think it's ln of 3x. F times g. F times g. Let me put erase that in between. So we need f prime, which is 4x cubed, times g, which is e to the power of 2x. And then we need g prime, e to the power of 2x, times 2, and then times f, x to the power of. We notice between 2 and 4, 2 is in common. Between x cubed and x to the power of 4, x cubed is in common. These two are identical. E to the power of 2x is in common. So 2x cubed e to the power of 2x. Now, what do we get from here? If we divide this one by this one, we just get number 2. So this is number 2. But if we divide this one, this goes away, and x to the power of 4 divided by x cubed, we get x. And that's the final answer. As you can see, a couple of algebraic steps. So this is f, this is g. Let's write them as follows. F, g, we are going to use the product rule. 9x gives us 9 times g x minus 1 to the power of 4 plus g prime. So we want to differentiate this 4 times x minus 1 cubed, and the derivative of the inside is just 1 times f, which is 9x. In other words, we have f prime g plus g prime f. And as you can see, between the two expressions, 9 is in common, x minus 1 is in common. This has exponent 4, this has exponent 3. We go with the smaller of the two, which is x minus 1 cubed. So when we divide this one by this one, just gives us x minus 1 here. When we divide this one by this one, x minus 1 cubed is gone, 9 is gone. What is left? 4x. And all we have to do, combine these two into 5x. We want to differentiate these two cases. Anytime you have a rational expression, the very first thing is, can I simplify? So I hope you notice I can make up two fractions. This gives me x. This gives me 4. So x squared divided by x is x. 4x divided by x is 4. And this is a simple case of a extended power rule. So 6x plus 4 to the power of 5 times the derivative of the parentheses, which is simply 1. So 6 times x plus 4 to the power of 5. This one, we use the extended power rule in conjunction with the quotient rule. So let's see how we do that. First, number 3 becomes a coefficient. Second, we raise this one to the power of 2. Now we need the derivative of the inside, which we'll use the quotient rule. So if we call this f and this one g, then we need f prime, which is 4 times g, 2x minus 9, minus, we need g prime, which is simply 2 times f, which is 4x, and then we write the bottom squared. So what we are looking at, this is f prime g minus g prime f over g squared. So all we have to do is to simplify this one. So we have 8x minus 36 minus 8x. These two cancel each other. So what do we have at top? What do we have at the bottom? So let's do it one more time so everybody is clear as to what goes in the numerator. The numerator has 3. The numerator has 4x to the second power. The numerator has negative 36. What about the denominator? It has 2x minus 9 to the power of 2 and 2x minus 9 to the power of 2. 2 and 2, they add up to 4. So notice, this is at top. 4x quantity squared is at top. Negative 36 is at top. And at the bottom is 2x minus 9 squared. 2x minus 9 squared. 2 and 2 is 4. So we take this to the second power, becomes 16x squared. Multiplied by 3 and negative 36. And we have minus 1728x squared in the numerator. The denominator remains unchanged. We want to differentiate this. We are going to use the quotient. You can think of this as the top function f, the bottom function g. So we need the derivative of the top. So f prime. So again, this is cosine. Gives us negative sine of the same argument, negative sine 5t. And then the derivative of 5t, which is 5. And then we're going to multiply by g. So f prime g, we are going to multiply by 5t. Then minus g prime f. What is the derivative of the bottom? 5 times cosine 5t. And the bottom is 5t. We square it to 25t squared. And we're done. We just have to take the factor of negative 5 out from the top. This 5, not the sign. This 5 goes away and 25 changes to 5. we have this answer, and this negative sign is the same as this one, which is not going to go away. So minus 5t sine 5t plus cosine 5t over 5t squared. For the next one, anytime we have a rational expression, we have to see if there is any way to simplify. Now, the only way this will be simplified if we have a factor of x plus 3 at top. If it can be factored, but it doesn't have a factor of x plus 3, it doesn't help. So look for x plus 3. It happened to be factored out, and it involves x plus 3. So you drop him. 2x plus 3, we know the derivative is simply 2. And that's the fastest way. Always look at any expression which is a fractional form, see if you can simplify it before you use the quotient rule. Can somebody read this question, please? Anyone? The growth in world population in millions is estimated by this formula. P of t equals 3100 e to the power of 0.0166t, where t is the number of years since 1960. Find the instantaneous rate of change for the year 2015. This refers to differentiation. We are going to differentiate P of t. So P prime of t is the same number that remains. It's exponential, the same thing, and times the derivative of the exponent, which just gives you the number 0.0166. So that's the derivative. So this remains. The function e to the power of 0.0166t remains, and the derivative of the exponent. You multiply these two, this is what you get. So from 1960 to 2015 is 55 years. In other words, 2015 minus 1960 is 55, and that's why we use this number here. Replace the t with 55, and at this point you have to use a calculator, and it gives you 128.2273 million people per year, meaning the year 2015, the world population was increasing at this rate per year, 128.2273 million people per year. That's the meaning of it. Anybody want to read this one for us? No one. The length of a growing Tasmanian devil is estimated by the function L of W is 2.265 W to the power of 2.543, where W is in kilograms and L is in millimeters. Its weight can be estimated by W of t 0.125 plus 0.18 t, where t is its age in weeks. How fast is the length of a 30-week-old Tasmanian devil changing? So that refers to the rate or just the derivative. So how fast is the length changing with respect to time? They're asking for dl dt. They're asking for dl dt. And according to the Leibniz's notation, if we have an intermediate variable, in which case we have the weight, or W, L is a function of weight, weight is a function of time, so we need the L dW, dW dt. So what is the L dW? just take the derivative of this function with respect to w. It's this number, 2.265, times this number, 2.543, and then w to the power of 2.543 minus 1, which makes it 1.543. What is dw dt? Simply 0.18. So this part is this part, and dw dt is just 0.18. We are going to multiply the numbers, and we get 1.036781 w to the power of 1.543. I like to carry out a lot of decimals, and at some point you just follow the instruction and see how many decimals they're asking you. So we wanted to see how fast it is in 30 weeks. So we need to find the weight when t is 30. So let's plug in 0.125 plus 0.18 times 30 will result in 5.525. And now we are going to replace it right here. To give the answer to the question, we replace it. And again, you use a calculator and it ends up being 14.4912, almost 14.5. What are the units? Millimeters per week. Why is that? The L, change in length, it's in millimeters, over dt, change in time, is in weeks. Quickly, if we wanted to do it differently, we would replace the W with this, and L becomes a function of time. We could differentiate this L prime of t or dl dt, which would be this number times the exponent. Then you write the same thing to the power of the exponent minus 1, 1.543. And then by the chain rule, the derivative of the inside, which is 0.18. Okay, so this number, the same parentheses to the power of 1.543. The derivative of the inside is by the chain rule. And you get this one. And now, again, I'm not going to continue with that. Now you can replace the t with 30, and it should give you the same answer. By the way, if they asked for what is L of 30, then you plug in 30 here to come up with the answer. So remember, you have to plug in 30 here, which we have already, and then plug it into here to find the L of 30. All right. So into this formula, we have to put, so 30 goes in here and whatever goes in here, and that's the length in 30 weeks if they had asked. I want to remind you about how to sketch the derivative function by reminding you that these points A, B, C are called local extrema, local max or mean, and it has horizontal tangent lines. Over here, the function is decreasing, so f prime is negative, same as here. Over here and over here, the function is increasing and f prime is positive. So if we were to graph it, notice at A corresponding to A prime, B corresponding to B prime, C corresponding to C prime, we have a slope equal to 0, so f prime equal to 0. To the left of A, decreasing below the x-axis, between A and B, increasing above the x-axis, but the reason it comes back down because at B becomes 0. From B to C is decreasing, so below the x-axis, but it comes back up again because that's 0. Then it's increasing, goes that way. As for this point, you try your best to draw a tangent line, and then when you do that, you pick up a couple of pairs, you calculate the slope, and the pair 5 comma 3 halves or 1.5 belongs to the derivative function. A function fails to be differentiable if it has a sharp corner, discontinuity, or a vertical tangent line. Therefore, if you want to graph this, then there are 1, 2, 3 sharp corners, and all of them get a hole because the function is not differentiable. Because there are 1, 2, 3, 4 line segments, each one has a slope of its own. So we calculate the slope for each case, assuming those are the pairs. We use rise over run, for example, for this one. M is y sub 2 minus y sub 1, 0 minus 1 over x sub 2 minus 1 minus x sub 1, which is minus negative 3, and it results in 1/2, negative 1/2. So the slope is positive 1/2 here, positive 1, negative 1 here. So if I were to graph this, then I need a horizontal line, y equals negative 1/2 from here to here. And at this point, I have a hole because there's a sharp one. Then I do the same thing for this one and the other one. So I need y equals 1. So it stops at this point, I have a hole. And at this point, I have a hole, and the rest of it. It's pretty straightforward, class. We want to find an equation of a tangent line. Well, we need two things. We need a pair. We can plug in and calculate. We need the slope. So we have to differentiate, which becomes 2x minus 3. And now if I plug in, that's my slope. So plug in here, you get 5. Plug in here, you get this pair. Y minus y1 equals m times x minus x of 1. So y minus 3 equals 5x minus 4, and you simplify it into y equals 5x minus 17. That's y equals mx plus b, or point slope. My apologies, slope intercept. This is the point slope. Let me just write it. This is point slope. This one. Slope intercept. All right, we want to differentiate this, and quickly we change this to x to the power of 1/2. And since this has exponent 1, 1 and 1/2, that adds up to 3 halves, 5x minus 2. Differentiation, we bring the 3 halves in front and we subtract 1, so it becomes 3 halves x to the power of 1/2 plus 5. And we know x to the power of 1/2 is square root of x. We change it and we are done. To differentiate this, we are going to change this to x to the power of 1/2, and we're going to put a raised dot in between. So we are looking at f g. So we differentiate this function, we get 1/2 x to the power of negative 1/2 times e to the power of x. Differentiate this function, gives it itself times x to the power of 1/2, and we write it as follows. F prime g as g prime f. And negative 1/2 goes down, becomes positive 1/2, and it becomes a square root of x. Now I've shown you how to come up with this, which means you can take a common denominator, and I can quickly remind you how we did that before. So this is e to the power of x. And now if I write this one just the way it is, e to the power of x times square root of x, then I have to raise it by a factor of 2 square root of x. That's what happens. And as you can see, this becomes x e to the power of x, and you can factor out 1 over 2 square root of x times e to the power of x, and you get that one. It's just a matter of algebraic techniques. This is f over g. So the answer is f prime, which is e to the power of x, times g, which is 1 plus x, minus the derivative of the bottom. G prime is 1 times e to the power of x, and you write the bottom squared. So just to make sure everybody understands, this is f prime g minus g prime f over g squared. And so when you distribute, you get e to the power of x plus e to the power of x times x minus e to the power of x. This cancels out this one, and you're left with this in the numerator. We put x in front of e to the power of x, and we are done. We are going to differentiate this as f times g. So f prime becomes 5 times the second piece. And the second piece is 4 times 3x minus 2 cubed times 3, and then times f, which is 5x. So quickly, this is f prime g. G prime f, and we can rewrite g prime f as 60x times 3x minus 2 cubed. As you can see, 5 is in common, 3x minus 2 cubed is in common. Also, I have mentioned that before, so I'm going to mention it again. Because this is a fairly small number, we can differentiate this way. But if this gets involved, you want to put this in brackets and do it. So when you divide this one by this one, gives you 3x minus 2. When you divide this one, this goes away, and 60x divided by 5 is 12x. And you can combine these two into 15x, and you're done. We write it as f over g. Derivative of the top is 1 times the bottom, minus the bottom gives you 4 times 2x minus 1 cube with the times 2, and then times x over 2x minus 1 to the power of 4 to the second power, so makes this one 8. I'm assuming everybody can see that. So f prime g minus g prime f over g squared. Now, if you look at the top, we can take out 2x minus 1 cubed. When we do that, this gives us 2x minus 1. And this one, this goes away. Minus 4 and 2x, they give us minus 8x. We can drop this one, and we change the 8 to 5. So the denominator is 2x minus 1 to the power of 5. We can combine these two into minus 6x. So we have minus 6x minus 1 over 2x minus 1 to the 5th power. Let's go over a couple of more examples just to make sure we are comfortable with that, something we had seen before. So let's go over them again. Observations show that the length L from nose to tail of a Siberian tiger has this formula, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its HT in days by function W is 3 plus 0.21 T. How long is it after 100 days? Well, we plug in T equals 100. As you can see, this is 21 and 3 is 24 kilograms. And if you plug it into W, you have the weight. We have seen this before, so I'm going to go over this pretty fast. So when you replace it, we get 969.369, close to 1,000. Remember, 1 meter is about 1,000 millimeters. Now we want the LDT, and the intermediate variable is W. So dl dw dw dt. The LD W is 0.25 times 2.6. W to the power of 2.6 minus 1, which makes it 1.6. And then dw dt is 0.21. So we have this one, and we have 0.21. We multiply this number, and this number. This is the answer. And when T is 100, W is 24. Since we've already calculated it, we just use that, we come up with the answer. The second method is to find L as a function of T by replacing W with this, and now start finding L prime of T, or dl dt. So this is L of 100, by the way, which gives you the same answer as here. And then if I want to differentiate 0.25 times 2.6, and then the parentheses to the power of 1.6 times 0.21, I simplify it. And if I replace the T with 100, we can come up with the answer. So this is another way of doing that. We had seen this before. This one we have seen so quickly. The amount of glass recycled in a community is G of P equals the square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that 10 years from now, the population of the community will be P of T equals 4.4 plus 0.1 T squared. How many tons of glass? It's in thousand. Will be expected to be recycled 4 years from now. So you replace the T with 4, and you calculate this. I hope you remember this one was done last time, and that's 6,000. Okay, that's P, 6,000 people. And now we are going to replace the P here with 6. And again, just reminding you that this is 36, and this is 18. 18 and 7 is 25. Square root of 25 is 5. 5 tons of glass. Using Leibniz's notation, we want dg dt. In part B, find the rate at which the amount of glass, dg, is changing with respect to time, dt. So we write this, and the intermediate variable is P. So dg dp, dp dt, and we are going to change this to 0.5 P squared plus 7 to to the power of 1/2. So we can easily differentiate by writing 1/2, 0.5 p squared plus 7 to the power of negative 1/2, and then times the derivative of the inside, which is 0.5 times 2p, makes it simply p. And so I'm showing you that's the case. And times dp dt, which is 0.1 times 2t, or 0.2t. And all you have to do, replace the p with 6, t with 4, as we did it last time. I showed that this one was 25. So this is 25 to the power of negative 1/2, or 1 over square root of 25, which is 1 over 5. And when you do the math, you end up with 0.48 units of dg over dt, tons of glass over year. So 0.48 tons of glass per year. That's at the rate at which is increasing, because it's a positive value. So the amount of glass recycled is increasing by 0.48 tons of glass per year. Four years from now. You want to differentiate this, I'm going to remind you that anytime we have a number in the numerator, you don't have to go with the quotient rule. We change this to the power of 1/2 and bring it up, make it negative 1/2. Now we're going to differentiate this. 4 remains. Negative 1/2 times x squared plus 3 to the power of negative 1/2 minus 1, which makes it negative. So negative 1/2. So x squared plus 3 to the power of negative 1/2 minus 1, which makes it negative 3/2. And then the derivative of the inside, which is 2x. And you're done. All you have to do, rewrite this. This 2, negative 2 times 2x, negative 4x. And you take this down, make it positive 3/2, or the square root of x squared plus 3 to the 3rd power. I've shown you that you can write it differently. So this is fine. You want to differentiate this, and I start with pausing when I read this as cosine. So y prime is negative sine of what? The same argument, 3t to the power of 4. And then 3t to the power of 4 has to be differentiated by the chain rule, 12t cubed, and we rewrite it. You want to differentiate this? We use the extended power rule. We put the 5 in front. And then the same thing to the power of 4. 5 in front, the same thing to the power of 4. And now we use the quotient rule. The derivative of the top is 2 times the bottom, minus the derivative of the bottom is 1 times the top over the bottom squared. So first, the top gives you 2 times x minus 8, minus the bottom gives you 1 times 2x plus 3 over the bottom square. So I hope everybody's clear as to what happened here. Just in case, this is f, this is g, f prime g minus g prime f over g squared. This is 2x minus 16 minus 2x minus 3, and the whole thing changes to negative 19. So we write this, and I'm going to write this as 2 pieces, 2x plus 3 to the power of 4, x minus 8 to the power of 4. You really don't have to do that, but because we want to combine these two, I hope you see the exponent is 2 here, the exponent is 4, they add up to 6. So I write it in this fashion. So 5, this one and this one, I separate them, and minus 19 over x minus 8 squared. So we clearly have x minus 8 to the power of 6 for the denominator. We multiply these two numbers and times this. We get negative 95 over 2x plus 3 to the power of 4 over x minus 8 to the power of 6. I want to finish this by reminding you about exponential functions. Anytime you have exponential function, the answer is itself. This times 10, so that's the answer. In this case, exponential, the answer is itself. The derivative here is secant squared. The answer is itself, it's an exponential function. The base is e, no, so we need to tag along ln3. And since this is x, you don't have to do anything, you just rewrite this and you're done.